Hey there everyone. This afternoon we're going to be doing lesson 4.5, chapter 4, section 5. It was our first day on graphing tangent. Eventually we're going to graph tangent, cotangent, and the other reciprocal functions, but today we're just going to focus on how to graph the tangent function. So if you have your unit circle handy, that will come into play in a second, and we're also going to possibly use some graphing utilities to explore it as well. The first thing we want to do is we want to establish, okay, what does tangent do as we increase the angle? So let's go ahead and plug in some values. If you look at your unit circle and you were to take the tangent of 0, the tangent of 0 degrees is equal to 0. So our first coordinate, just like sine of 0 is 0, tangent of 0 degrees is a ratio of 0. The next key element to tangent is, if you notice, when tangent is taken of pi over 4, tangent of pi over 4 is equal to 1. So the next coordinate that we usually plot for tangent is pi over 4, comma 1. As you go around the unit circle, the tangent of pi over 2, there's a unique circumstance there. The tangent of pi over 2 is actually an undefined value. Because you're dividing by 0, because the cosine is 0 there, tangent is undefined. And so we don't have anything to plot at pi over 2. If we keep going around the unit circle and move into the second quadrant, the tangent of 3 pi fourths, in the second quadrant, tangent is entirely negative. So tangent of 3 pi fourths will equal negative 1. And if we keep going around the circle, tangent of pi is back to 0. So we have these last two coordinates. At 3 pi fourths, we're at negative 1. And at pi, we're at 0. And this is actually a completion of the tangent cycle. Because we started at 0, we went to 1, and then we went to our negative values, and we're back to 0. So we've actually completed a period for tangent. And that's the first major difference between tangent and sine and cosine, is that the period for tangent, at least the parent function for tangent, is equal to pi, as opposed to 2 pi, which was sine and cosine. So let's talk about the equation itself. Our parent function is just going to be y is equal to the tangent of x, or theta, whichever you want to think of it as. But if we put in our parameters, y is going to equal a times tangent of b, parentheses, x minus c, plus d. C and d will still represent horizontal and vertical translations accordingly. B will affect the period of tangent, and a isn't our amplitude like it was for sine and cosine. Instead, it's called the stretch factor. So it's going to stretch our graph a little bit. But how can we solve for the period? Well, normally the period for tangent, at least the parent function, is pi. But if we have a multiplier here for b, if we have a value inserted for b, that's going to change the period. So in this case, period would be equal to pi divided by b. Note that it's different for tangent. For sine and cosine, it was 2 pi over b, but anytime you have a tangent or a cotangent problem, your period will be pi divided by b. So now that we know that, we can go ahead and start sketching our graph. And just like we did for sine and cosine, we want to establish a scale for our axes. Since we're just doing the parent function, I'm going to count out 4 tick marks. And we're going to divide the cycle for tangent into fourths, just like we did for sine and cosine. The period for tangent is pi, however, so on the 4th mark we're going to start that at pi, which would mean that the second mark right here, this mark is pi over 2. And my other 2 marks are pi over 4 and 3 pi over 4. And this is really convenient because those are all of the inputs that we had some distinguishing features to graph. So let's go ahead and see what they're going to look like when we graph them. We start with a coordinate at 0, 0. At pi over 4, we have the ratio of 1. So on my y-axis, I'm going to set this to equal a ratio of 1. So at pi over 4, I'm up 1. And at pi over 2 I'm undefined. Now what does that look like in a graph? Basically undefined means that there is no input that I can plot at pi over 2. So to denote all of the points that cannot exist, we are actually going to draw an asymptote. The asymptote will be placed right on top of pi over 2. Because we can't plug in pi over 2, we get an undefined answer if we try to. Okay, if we go to the other side of the asymptote, to our third interval, 3 pi fourths will be down at -1. And we'll be back at 0 at pi, completing the cycle, completing the period. So you may be wondering what happens as we get how we would connect these points. Well, the curve for tangent looks a lot like an exponential growth, because as we get closer and closer to 90 degrees, or pi over 2 radians, the value for tangent gets larger and larger. It will in fact keep getting larger and larger as long as we don't hit 90 but just approach it. Once you have passed 90 degrees, if you go just a little bit past 90, you get very large negative values for tangent. So the next part of the tangent curve comes from -infinity, goes up through -1, and then comes back at 0. Okay. This is one full period for tangent. So from 0 to pi, that's the distance for the period. There is no amplitude, but remember that a will act like a stretch factor. So if there is a value a in your tangent graph, that's going to stretch this value. So where it would normally be 1, if you have an a, you would take 1 and multiply it by a to get the new coordinate for this distinguishing characteristic. Same thing with negative. So you would stretch the negative down, however large a was. Okay. C and D will operate just as usual. They'll shift the entire graph, including the asymptotes, left, right, up, or down. Okay. Let's go ahead and graph one more period for our parent function. So we're going to continue this pattern. I'm going to draw 4 more tick marks. 1, 2, 3, 4. Extend the period. The first period was pi. This period would be 2 pi. And I'm going to draw my asymptote halfway, which would be at the second tick mark from where I started. And my coordinates will be right here at 1, at -1, and then I return to 0. So I'm going to continue the graph here, and then here as well. Okay, this would be 2 periods for tangent now, because we've completed the cycle once and then completed it again. A lot of the tasks are going to ask us to identify the location for the asymptotes. So the asymptotes we would describe as vertical lines, which is written as x equals. These are all the values where x is equal to pi over 2. These are all the x values where x is equal to not pi over 2, not pi, but 3 pi over 2, 3/2 of pi. Okay. Notice that the distance between the asymptotes, the distance from pi over 2 to 3 pi over 2, is always the same as the period. So the period was pi, that's also the distance between my asymptotes. So knowing this, if we can find one asymptote, we can actually find all of the asymptotes in the graph. If we want to identify them all, we would say that the asymptotes occur at y equals, start with the first one you found. My first asymptote was at pi over 2. And every other asymptote that's in this cycle will occur every pi units. So I'm going to add pi to this however many times I wish. And so I'm going to say pi n times. So you could add 2 pi, 3 pi, 4 pi, whichever amount of pi you want. Just make sure that n is some integer value. So we'll say that n is an element of the integers. Okay. This would describe every single asymptote for the graph. Remember that this is your period. This may change when you get a different b. And this is the location of your first asymptote. This may change if you shift the graph, or again if you have a b. N will be the same no matter what. So let's try one with a modified graph, not the parent function. but if we modify this and create a value for b. So we're going to graph the tangent of 2x. First thing you want to do is identify the new period. So the period is always equal to pi over b for tangent. This would give me a period of pi over 2. On my coordinate axis now, I'm going to mark this as my y-axis, my x-axis. I'm going to create my 4 tick marks. This will be pi over 2. Halfway would be pi over 4. I know that tangent, much like sine, starts at 0, 0. And I'm going to mark my y-axis as a 1 ratio here and -1 ratio here. And so after 0, a quarter of the way through the cycle, I'm up at 1. Halfway through the cycle, I'm approaching infinity. I'm approaching this asymptote that I cannot plug in. I cannot plug in pi over 4 because if I do, I'd be taking the tangent of 2 times pi over 4, which is tangent of pi over 2. Tangent of 90 degrees or pi over 2 is undefined. So I'm just checking my work there. That makes sense that the asymptote is at pi over 4. And once I'm 3/4 away, I'll be at -1. And at pi over 2, I'll have completed the cycle. I'm going to go one more period over. Draw 2 periods for tangent. This would be a complete pi right here. If we go all the way to pi, this would be 3 pi over 4. That's going to be the location of my next asymptote. Notice that pi over 4 and 3 pi over 4 are pi over 2 apart. They're always the period distance apart. Plot my +1 and -1 at a quarter of the cycle and 3/4 of the cycle. Okay, and there's 2 periods of tangent. It does say to locate the vertical asymptotes, so I'm going to say that the asymptotes are at y equals pi over 4. That's my first asymptote, plus the period pi over 2 n, where n is some element of the integers. Okay. The only thing that may change when you're working on the homework problems is if you have an a. So imagine if I took this same graph and I multiplied it by 2. 2 times tangent of 2x. The only thing that would really change is that all of your outputs, all of your ratios would be doubled. That's not going to affect your zeros because 0 times anything stays 0. So these points right here are going to stay the same. So I'll do this modified graph in blue. The zeros are going to stay the same, but the ratios that are given here are going to be doubled. So instead of being at 1, I'm going to actually be up at 2 now. And instead of being at -1, I'm going to be down at -2. So if there is a multiplier in front of your tangent graph, it's just going to make it stretch slightly faster. So it'll look something like this. And that would continue into your second cycle as well. So I'm going to stretch these points. And so you'll see a slight change in the bend of tangent. Okay. All right. I have a couple of practice problems for you if you'd like to try these on your own. I'll put the answers up right after the break right here. Okay, so here are your 2 solutions for these 2 graphs. Make sure that you have your period solved for and that you have your equations for the asymptotes written. I noticed that I had a mistake on the previous slide. It should be x equals to represent the vertical lines, not y equals. So make sure when you write your expression or your equations for asymptotes that they're x equals, not y equals. Okay, hope this helps you with your understanding of tangent. Just remember, if you do have a multiplier, that these outputs will be stretched vertically. Okay, have a great day.